Now we're going to begin to look at some manipulations of the sine and cosine and how they're going to affect the graphs. So the first simplest manipulation we can look at is taking the sine or cosine and multiplying it by some number. So here a is just any real number that's non-zero. Now, if you've taken or you are taking Math 22 and you've done graph manipulations, this is exactly the same as the sort of thing you're doing in Math 22. However, in this class, we're going to be a little bit more visceral about it and actually plot some points as opposed to talking about more abstract ways to think about how the graph gets manipulated. Regardless, whenever we take a sine or cosine graph and multiply it by some number a, when we're multiplying that function by some number a, that is going to serve to multiply the y-coordinates by a. So the idea is that the graph doesn't move horizontally because we're not doing anything to the x's. It is going to shift vertically, and the way it's going to change vertically is via a stretching or shrinking. Okay, so if we think about taking the graph of the sine function and multiplying the y-coordinates of all the points by, let's say, 2, going from sine x to 2 sine x, what that is going to do is stretch everything out by a factor of 2. So we're going to get a vertical stretching if we're multiplying by something that has an absolute value greater than 1. We're going to shrink our graph if we were to multiply our y's by like a half or a third or negative a third, something that has an absolute value less than 1. In addition, if we multiply our graph by a negative number, we're going to be taking the negatives of all the y's, and that's going to flip us upside down. That's going to reflect us across the x-axis. Okay, and that's the case if a is negative. The only restriction we have on a is that it can't be 0. If a is equal to 1, then we're just dealing with sine x or cosine x, so that's not very interesting. We can multiply by a positive or a negative number. Okay, so in general, what that means is that our range, where our y values go, will now run from negative the absolute value of a to the absolute value of a. Okay, or if you like to think about this using inequalities, y is going to run from negative the absolute value of a to the absolute value of a. So the reason why we have to fiddle around with these absolute values is, again, because a could be negative. So we want to make sure this first number is always negative, the second number is always positive. So that way our inequality is in the correct order. The lower number is first. So if we take the absolute value of a, regardless of what a is, we're ensured that's a positive number. Then we take its negative, and we're ensured that we get a negative. Similarly, here on the right, if we take the absolute value of a, no matter if a is positive or negative, we're assured we're going to get a positive number over here. This will also affect our amplitude. Okay, so our amplitude is going to become the absolute value of a. So again, an amplitude you can think of as being like a distance, so amplitudes can never be negative. So even if we flip the graph upside down, the amplitude is still going to be a positive number because we're still going up and then down in our wave. Okay, so let's go ahead and do an example. If you understand graphs of sines and cosines, this is a really straightforward alteration. So let's take a look at the graph of y equals negative 3 times the cosine of x. Okay, and if you're not really convinced yet of what I said about multiplying the y-coordinates by our a, in this case our a is negative 3, we can plot some points and then do our graph that way. So let's go ahead and just pick some angles x. And here we can just let x run from 0 to 2 pi. So we'll do 0, pi over 2, pi, 3 pi over 2, and 2 pi. In general, whenever you're plotting a sine or cosine graph, you really just need to plot 5 points. So basically you plot the beginning and the end of the period, and then you break that period up into fourths, so you're going to have 5 points here. You're going to have a start, an end, and then you're going to have 3 more quarter points. If you have those points, and these are the nice ones to graph because they're going to be either maxes, mins, or y-intercepts in this case, you can just connect the dots. That's something we're going to exploit later on when we do some more tricky graphing. Our y is going to be negative 3 cosine x. Okay, so when x is 0, y is negative 3 times the cosine of 0. Cosine of 0 is 1, so y will be negative 3. When x is pi over 2, y is going to be negative 3 times the cosine of pi over 2. Cosine of pi over 2 is 0, so negative 3 times 0 is 0. When x is pi, y is going to be negative 3 times the cosine of pi. That's going to be negative 3 times negative 1 is 3. When x is 3 pi over 2, y is going to be negative 3 times the cosine of 3 pi over 2, which is 0. When x is 2 pi, we're going to be back where we started. Y is going to be negative 3 times the cosine of 2 pi, which is negative 3. So if we look at our graph, okay, so x is 0, y is negative 3. So now we're going to start down at y equals negative 3. This is the flipping upside down because our a is a negative number. So we're going to start with the reflection across the x-axis. When x is pi over 2, y is 0. When x is pi, y is 3. When x is 3 pi over 2, y is 0. When x is 2 pi, y is negative 3. Okay, so now we connect our dots. It's just going to be one period of our graph, but again, when we get that one period, we can just copy it over and over again and get more of the graph over multiple periods. Okay, so this is what our graph is going to look like. So we see that, this looks a lot like a sine or cosine graph. The overall shape doesn't change. In this case, the only two things that have changed, well, three things. The first is that it looks like a cosine graph flipped upside down, because now we're starting at the relative minimum instead of the relative maximum. Our range is negative 3 to 3. So our lowest y point is y equals negative 3. Our highest is y equals 3. And then our amplitude is 3. Okay, because now the distance from our lowest y to our highest y is 6. Half of that will be 3. So now we're going, if we start at the x-axis, we'll go up 3, back down, down 3, and then back up. So we have the sort of average height of our wave of 3. Okay, so that is our first manipulation of our y values. In our next video, we'll look at what happens if we multiply our x by something.